let's let's begin. Happy Halloween, everyone. I hope you had a good weekend, and we'll take a look. So we left off on Friday, and we were talking about matplotlib, and we ran out of time. We didn't get to talk about some of the integrated functions that Panda has, or at least Pandas has kind of things built in to use matplotlib. So there's a lot of libraries, matplotlib being the kind of primary data visualization and plotting library that we use in Python. A lot of kind of things work with that and allow us to kind of create images. So here I have an example where I created a time series, okay, or just basically a series of values that go up and down, and you can just take a series, okay? So this is a series, there's values and an index, and here the index is a date, and if you've specified that the index is a date and you call ts.plot, it's going to plot the date on the horizontal axis there, okay? Let's say we have, so I have different examples here. So here I have now a data frame where the index is a date, and I've got columns A, B, C, and D. And you can just call, you can create a new figure. So using PLT, again, at the very beginning, when you load your libraries and stuff, you always do matplotlib.pyplot as PLT, right? And so a lot of times when you open a notebook, you're going to see all of these import this and that. And so almost always you'll see import numpy as NP, import pandas as PD. And then if there's any graphics, you'll see import matplotlib.pyplot as PLT. So scrolling back down to here. So plt.figure just kind of creates a new figure. And here I just said df.plot, plot the data frame. I'm using the plot method for the data frame. Again, because it recognizes the time series at the index as dates, it's going to create, put dates along the x-axis. And here it took the 4 columns and it just kind of plotted each of those lines, and it automatically creates a legend. So these are all kind of just default settings, and any of these things you can kind of customize a lot of this stuff. And so you can just you can always look up on, online, like, how do I move some of the stuff? If you have a kind of just a single series, you can also create a bar plot. This one looks a little funny because I've got a negative value. And so the bar plot actually goes negative here. But you can just, take any kind of thing. If you got some values and an index, you can do kind equals bar, and it will create a bar plot. So, this was just, I took one arbitrary row out of the data frame, but it could be, you could imagine your data just being formed in any other kind of thing. So here, some of the different options for plot is listed off in kind. Let me just, again, open this reference page on the different things. And so I'm only going to cover a few of these examples. So the default is line, but the others are bar, and you have horizontal bar and hist and box and things like that, kernel density estimation. And I recommend that a little bit on your own time, you just try out some of these different kinds when you take a data frame and you do .plot, data frame .plot, see what kind of things result for different kinds of data and different kinds of plots to create. All right, so here, and this is also quite useful. So here I've got some data frames, and or another data frame, and I have two kind of categorical variables with different values in here. I just filled it out with different random numbers, okay? But I don't know what this is, right? millions of dollars from each sector or whatever. So we got California, and we have this, and New York is this, and Texas. I'm just making up numbers, all right? So these are random, so don't get mad at me that I said there's 0 tech in Texas or something, okay? So, you know, if you have something like this, then you can do dataframe.plot.bar, okay? And this will create this plot. You can add a title, and it kind of goes through and says, okay, you know, the tech, you have 8202, and it, you know, plots it like that, okay? And so the index goes on the X, and then the different columns become different colors here. If you wanted it the other way, where you have the states, and you want the you know, the index to be the different colors, you can transpose. You can transpose your data as well. I think this also works. Okay, so I could also just do dot plot kind equals bar, or plot dot bar as similar kind of ways to do that. Okay. If you don't like the positioning of this legend and you want it on the outside, there's an option. You can do plt.legend, and you can specify where you want this to go. Location upper left. I think I can also it's where does this get anchored? Yeah, upper left. I don't want to mess with it too much. But yeah, so if you want to kind of move the position of the legend, you can do it. And probably, you know, a lot of times you'll have to look online to look up reference on how to do something like this. Okay. With a bar plot, you can also stack them. So rather than having the side-by-side things, you can stack them, and you can kind of have them. And again, you can transpose, and they will, you know, so here I have the 5 different sectors and 4 different states represented within each sector, or you can take each state and show the different sectors within each state, right? So this is kind of what you have. So those are bar plots, and I think stacked bar plots are also useful. Again, look up the help. Look up the help. Okay. Here is if you take a data frame and create a histogram. This is what you can produce. All right. So here I have the data frame. I have 2 columns. One column is 1. And it consists of 60,000 random integers from 1 through 6. And then column 2 takes the integers from column 1, right? And then it adds additional values from 1 through 6 to them. Okay, so this is what it produces, and we end up just getting. Here we get uniform for blue, and then we get basically a triangular distribution, like dice rolls. This is like the outcomes after 1 dice roll, and this is the outcome, the sum after 2 dice rolls will look like this. And that's distribution 2. Okay. And then if we wanted to, we could do column 3, column 4, and what do we see? We see, you know, as you add more dice rolls, then you get something that looks more and more normal, right? So the mean outcome after several dice rolls, you know, keeps shifting to the right, and then the shape becomes more and more normal looking. Well, anyway, this is just kind of running different kinds of things. So this would be plot kind equals hist, and then with additional arguments there. All right. So plotting directly from Pandas data frames is quite useful. And again, look up the reference here. Try it out yourself. That's really going to be the best way to learn, is try creating some of these things yourself. All right, today I also want to take a look at a package called Seaborn. Okay, so Seaborn works with Matplotlib, and it just kind of like shortcuts for, I don't know, pretty plots and it makes kind of the creation of some of these exploratory data analysis plots, nice and convenient for us. So it runs off of Matplotlib. So you need to do matplotlib.pyplot as PLT. You also need to import NumPy. You need to import pandas. And so let me do that. All right, and then what we will look at is we'll look at one of the data sets included in the Seaborn package. Sorry, I have to create your view quiz here. All right, and so one thing to just keep in mind is that Seaborn is for visual exploration. There you can kind of fit like a trend line, all right, like a linear model or logistic regression model to the data, but this is for visual exploration, and Seaborn actually won't let you it won't let you extract like the coefficients from your linear regression. So like you say, hey, fit a linear regression line, and it'll draw a trend line, all right, and it'll be found using least squares regression, but it won't let you say, hey, what is the slope and intercept of this least squares regression line? Okay, it's like against the philosophy of Seaborn. Seaborn just says, hey, I drew a line here, but this is just for kind of visual exploration. Like you can look at this line and you can see it has a different slope from this line, but don't try to do some kind of significance test or something like that. So there's kind of a philosophical thing where Seaborn's not going to let you do certain things. Okay, so let's go ahead and load up the Penguins data set, and this is the data in the Penguins data set. Okay, so I don't know, there's different species of penguin, okay, and I guess there's different islands. So you can look up where this island is, the Torgerson Island. Okay, so it's this tiny little, the image is not there, okay? But it's a tiny little island off of Antarctica. And I guess people went down there to look at penguins, and then they I don't know what they do. I guess they catch some of the penguins and then they measure them, and I guess they let them go or whatever. And so they said, all right, let's measure the bill length and the bill depth and the flipper length and flipper depth flipper length, body mass, and male or female penguin or something like that. All right. And so we measured a bunch of these. There's Adélie penguins on this island, Adélie penguins on this island. There's a whole bunch of penguins, okay? And we can I can create a plot. So one of these things is the distribution plot, okay? sns.displot, and here we're going to say data is coming from the data frame penguins, which is what I have. And we're going to specify the variable that we want to plot. So we're going to say x is flipper length millimeters. So we're going to just take this variable. So you specify one of the column names. And then again, it runs off of matplotlib. So at the end, to kind of show your plot, you'll call plt.show. So I run that, and there you go. This is a histogram. Okay, that's basically the distribution plot is basically a histogram that that does this. Okay, there's additional kind of things that you can do. So you can, with the distribution plot, it kind of defaults to creating a histogram, but you can also add what's known as a rug plot to it, okay? And here I changed the number of bins. I said 20 bins. And you can kind of see on here there's little ticks, and these kind of indicate the values that we see in the data. It's because the flipper length was measured to the nearest whole number, the rug plot doesn't do a great job, okay? Because we have like a whole bunch of penguins with the same flipper length. All right, so I've got a whole bunch of penguins with flipper length 180, 180.0, and they all just show up as, you know, one kind of tick here for 180. So, you know, if it was truly a little bit more continuous, then you'd get a sense of how much density you have of these things. In this case, because it's, you know, measured, the true value is discrete. I mean, is continuous, but it's measured in a bit of a discrete manner, right? And you could imagine you get a penguin and you're trying to measure its flipper length. Like if I told you measure your arm length to the nearest millimeter, you know, no one's going to come back and say, give me like tenths of a millimeter, right? Like I don't think it would be a feat just to get to the nearest millimeter in of itself, and then to the nearest tenth of a millimeter. I think, you know, that's asking for a lot for a penguin too. All right, but anyway, you know, here's a couple, like this is silly. Bin width 2. All right, you can specify how many values you want in each bin, and you can see, oh yeah, you know, with the rug plot, there's really only kind of 2 tick marks that appear within each bin. Okay, so you could specify the number of bins. Here I say I want the number of bins. Here you can specify the bin width. You can also specify your cut points, and they don't necessarily have to kind of span the entire data. So here I started off at 170, and I end at 200, and that's it. All right, this would be very misleading if you didn't tell people that this is truncated. All right, I wonder, like, can I have different? Yeah, so you can have bins of different width too. All right, so it's weird and not recommended, okay, to have bins of different width, but it is it doesn't break say the plotting. You can also add an option to the distribution plot. So to the histogram, you can add a KDE, okay, kernel density estimate, which is basically like take your histogram and draw like a smoothed out curve, and that's an option that's available. All right, so you can all of these things. So you do, you know, sns.displot, specify, you know, what variable you want. KDE equals true adds this, plt.show. All right. If you do kind equals KDE, right? So instead of KDE equals true, if you change your distribution plot and you say kind equals KDE, then the only thing you get is the kernel density estimate, right? Instead, so the default kind is a histogram where you can kind of add some of these options, but you can also kind of change some of these things. You know, and again, all of these things, you can go manually and create this using Matplotlib. You can, you know, Matplotlib has a histogram thing. You can kind of customize it. You can kind of try to coordinate adding these things. Seaborn just makes it easier to do a lot of kind of, I guess, common plots that you would want to do with Matplotlib. It doesn't have as much customization as, say, like ggplot, where you can like really fine tune a lot of these things. These are kind of like common templates, and you use Seaborn, and it's intended to do it kind of in a quick fashion. Sorry, let me I need to enter this. Okay, so your first view quiz answer today is the letter D. D as in dog. D as in dog is your first view quiz answer.
The view quiz isn't published.
It's not? I think, okay, try refreshing. I think I just published it.
It's part of an unpublished module.
Part of an unpublished module, okay.
Yeah.
Man, all right, how do I do this? Oh yeah, okay. Okay, how about now? D. Works now, great. D as in dog. All right, and then the last, I know about the last. There's probably, here, let me look up. Seaborn dist plot. What are the options here? Oh, dist plot. Okay, sorry. I wrote dist plot, right? Yeah, they used to have dist plot, sorry. And now it's dist plot. Dist plot is deprecated. Okay, seaborn.dist plot, and you have, yeah, kind equals hist, kind equals KDE, kind equals ECDF. Okay, so ECDF being the empirical cumulative distribution function. So what does this thing look like, right? It starts off at 0, and basically it ticks up until it reaches 1 as the values increase, right? So basically, it looks at all of your data. If you have 100 data points, you would have like 100 steps, and each kind of step corresponds to like a different percentile. But now it's like, so this would be, 60% of your data have values below, I don't know, whatever this is, 205, right? And 100% of your data has values below 230, and none of your data have values below 171 or something, okay? And so this just kind of ticks up. That's the empirical cumulative distribution function. All right, other plots. So if we look kind of at our data, we see, we got several numeric variables. So I can say, all right, let's look at x and y, right? The dist plot here, when you have two variables, is going to create like a heat map, and it's going to say, okay, what combinations of flipper length and bill length are most common? We can say, okay, there's kind of a lot of penguins with flipper lengths around 190, 185, 195 between there, and 35 and 40, I guess. There's also some penguins over here. And so this is kind of the default distribution plot. You can do KDE, and this does a kernel density estimate, and we say, oh yeah, you know what, there's kind of three, I don't know, zones of concentration, right? You can also add the rug plot here. And so here the bill length was measured a little bit more precisely, and so you can kind of see the density of each of these values a little bit more closely. Here you can also this I'm going to do two variables, but one of the variables is categorical. Okay, so one of the variables being categorical, if I do a dist plot, I'm going to basically get a histogram, or actually in this case, I'm saying kind equals KDE. I'm going to get three kernel density estimates with a different color for each species, right? So here I'm plotting two variables, and we can say, oh, you know what, this is the breakdown of for flipper length. So when you look at kind of the overall kernel density estimate, we get this bimodal thing, and we can say, oh, you know what, it's underneath it, we have kind of three species, and they overlap like this, and that's why we're seeing kind of the bimodal structure in our data. The Adelie and the chin strap kind of overlap each other and form one peak, and then the Gen 2 or Gen 2 penguins have a different average flipper length, and so they form the other peak here. So we're looking at, again, two variables. One is numeric, one is categorical, and we can get something that looks like this, right? Instead of KDE, if we have multiple of these things, we can just leave it as a histogram, and we can say, you know, stack the values, right? And so this histogram, if you ignore the color, the shape of that histogram matches this, right? So this histogram and this histogram is the same, but here we've now broken down each of those bars with different colors, and we can say, oh, okay, you know what? Yeah, this peak is due to the Adelai and the chin strap kind of overlapping, and here's the peak because of the Gen 2. Beyond the disk plot, you can also create what's called the joint plot, where you have two numeric variables. With two numeric variables, the joint plot is basically going to create like a scatter plot, flipper length and bill length. So very similar to what we were doing here, flipper length and bill length, but rather than just kind of the kernel density estimate or the heat map here, we see the actual dots. Okay, and then the thing about the joint plot is it gives you a histogram for each variable by itself. So this is pretty much this histogram just kind of squashed down, right? So you can see this shape is right here, just squashed down and just in one color. And over here we have the other, right? And if you want, you can take this same joint plot and you can add a third variable, right? And here I'm saying hue is equal to species, and we see, okay, now we've colored each of these things, and we see, oh yeah, you know what? There's three clusters of penguins, you know, when we look at these two variables together, and we could really very much kind of guess which species of penguin is based on just the combination of these two variables, flipper length and bill length. Okay, and we get we get the kernel density thing. This basically this plot that we created is right here, just kind of squashed down. And similarly, you can imagine doing something similar for the bill length and do this. So the joint plot is actually pretty nice when you have two numeric variables. I think this is a pretty handy plot. And to kind of create something like this in Matplotlib, again, is possible, and you could do it because Seaborn is actually running off of Matplotlib, and so you could do it yourself. It's just, why bother, right? Why, you know, if you wanted to create this in Matplotlib, you'd have to do the like that grid map business, and you'd have to kind of create, you know, an area up here and an area for this thing and an area over here, and you'd have to do all of this, and it's a headache. Why bother when you have like just this one nice shortcut that does this? So Seaborn really facilitates a lot of this visual exploration, and that like it creates some things that I think are a common thing that it's kind of like these certain templates. Again, if you really wanted like a custom thing, Seaborn's, it's not easy to like really customize it beyond kind of what the templates that you have, but the templates are really nice and useful, and I definitely think they were created by like a statistician who like knew what kind of plots would be useful versus like, and well, you know, Excel has gotten a lot better. I think they probably hired some statisticians on their team to like make things, but it used to be back in the day, like the selection of charts you could make in Excel were like really limited. Now that it's a lot better. It's actually like you can do some really cool stuff in Excel, and I'm like, oh, you know, like we could actually teach courses in Excel, but I'd get shunned by the rest of the department. Anyway, and then if you don't want the dots, you can do kind equals KDE, and you'll get like I don't know, some kind of kernel density estimate plot for each of these species alone here. Okay, which is kind of cool too. I think this one's probably your most useful one there. All right. I guess this is just a little showcase of things you can do in Seaborn. Okay, if you have a whole bunch of numeric variables, so we can take a look at the iris data set. The iris data set has 4 variables: sepal length, sepal width, petal length, and petal width. And there's 3 different species: Setosa, versicolor, virginica. And so here, if you have like numeric variables, you can just create pair plot, okay? And it will create pairwise things. So it's going to plot sepal length versus sepal width. And then when it's like sepal length versus itself, it creates a histogram here, which is nice, right? Like, I kind of wish when R has a pair plot thing, and I wish they put histograms down the diagonal rather than just put the variable name. So, but anyway, this is what we have, okay? And then if you wanted to, you can color the dots, right? We have another variable for species, and we can color the dots. And look, this is so great. Is it not? Okay. And so we see the 3 different species being plotted in, you know, kind of the respective colors. And, you know, you really do see like kind of the structure here, you know, for petal length. You see for Setosa, the petal lengths are all very concentrated around this value. And, you know, we see the kind of the 2 distributions for versicolor and virginica. And then, you know, these other variables, there's, you know, kind of more overlap and more overlap here. But probably, you know, just these, with just these 2 variables, petal length and petal width, you know, you can almost just go right along this diagonal and just create like a cut line here and a cut line here, and you could probably separate out the 3 species really easily there. Okay, let's look at some more data. And so there's another data set. This is the TIPS data set. I have no idea when this data was collected, and because like these numbers are like, they're like so crazy to me. So this was like a dinner for 2. The total bill was $16.99, and they left a $1 tip. And there's sex and smoker and day and time, and I don't know, is this the sex? This was like they were like for a restaurant, and they were like collecting data for like the different waiters, how much tip they got, and I guess it was like what day of the week it was, and this was like back when you could smoke in a restaurant, and was the person a smoker or not, and as far as the sex goes, I don't know if it was the sex of the server or the sex of the patron. I don't know. You'd have to look this up. But anyway, this is kind of what we have, right? Here's a dinner for 3 people, and the total bill was $10.34. It's like, you can't even buy 3 drinks for that much, right? Like 3 sodas is going to cost you $11, and if it's boba, then it's $30, right? So, you know, and the you know, I guess this is a 15% tip there. So, that's what it is. But anyway, let's you can ask tips.info, and we have like 244 observations. Okay, let's take a look at some of these things. One of these things is the strip plot, and here we're going to put on the x-axis the day of the week. All right, Thursday, Friday, Saturday, Sunday, and we're going to look on the y-axis the total bill. Now, this is not great because there's so much kind of concentration here that we can't differentiate the things. So here right now I have jitter equals false. You can turn jitter on equals true, and it puts a little bit more spread, and you can see a little bit more kind of scatter in the data here. And you can see, you know, there's greater density of points down here and less up here, and so on and so forth. There is something similar to this. So this is the strip plot. So the hardest thing with Seaborn is getting used to the names of what it calls, right? I probably would have called this like a dot plot or something, but they call it a strip plot. Okay, and then they have something called a swarm plot, which is pretty much like very similar, except they tried to like avoid any kind of overlap, and they arranged the dots in, I guess, a swarm. So no overlap of the circles here. Okay, and it's like, okay, let's, I don't know, whatever this shape is. Okay, so you can have that. All right. With a swarm plot, or even with the strip plot, here I have one categorical variable along the x. I can actually take this and put another categorical variable, right? And so here, I'm going to do hue equals sex. So the categorical variable will do this, and so this will take the dots and color them. All right, so it takes our swarm plot, and this right now they're colored by each kind of the categorical variable day, and now they're colored by the categorical variable sex, and that's what we have here. Okay. You can, if you swap this, so I think this is okay. I don't know, it's not my favorite. But if you swap this, if I put sex on the x-axis, now we're going to have two positions on the x-axis, and then I'm going to put day as the color, hue, and now we'll have 4 colors, one for each day of the week: Thursday, Friday, Saturday, Sunday. And this is just, this hurts my eyes. It looks like, I don't know what this is, like a Christmas tree, all the colors, but to me, I'm getting nothing by having the day of the week colored. Okay, it's like it's hard for me to see any patterns here. So unless like your data is very clearly like all of these are one color and all of these are another color, all of these are another color, it's hard for me to really see any kind of patterns with the color here. I do see, like, overall maybe the male numbers are higher than the female numbers, and we have more male than female as far as dots total go, but I'm not gaining anything by having the dots colored by day of the week. All right, you can do box plots. Box plots, we're used to those, right? So that's that. And then similarly, so here I put day of the week, and we can say, oh yeah, you know, Saturdays and Sundays pull in a little bit more money than Thursdays and Friday. If you wanted to switch it to be horizontal, you just, now I put y to be the categorical variable and x to be the numeric variable, all right? So we do that. Here I can also separate them by, say, the sex, and now we will have 2 different colors, and they're going to be side by side, okay? And so on Saturday, the averages are around the same, but yeah, you know what? On the other days of the week, and I don't know if it's, again, I should look at the data. Is this like the sex of the server or sex of the patron? But if it's like the sex of the server, that's like messed up, right? Like they're getting in like smaller bills or less tips or something, but I wouldn't put it past people who, we all know people suck, right? So, okay. So we have that, okay? And here is, there's another thing called a violin plot, and, you know, it's like a box plot, but instead of a box plot, it's like having like a KDE on each side. So here I'm going to have, so the arguments are pretty much the same. X is day, Y is total bill, hue is going to be sex, data is the tips, and here I'm going to do split equals true. And the violin plot is basically, instead of a box plot on the left and a box plot on the right, it's like you have a kernel density estimate, like a smoothed out histogram on the left and a smoothed out histogram on the right, okay? And it creates this thing, and this is equivalent data as this, and so we see, you know, for Saturday, you get something that looks like this, and I don't know, but yeah, not the greatest. Okay. Facet grids. Facet grids are handy and useful. And basically, a facet grid will create the same plot, but split up and separated for different subgroups. Okay, so here I specify row equals sex. So we're going back to the penguins data set, and you can add another variable, right? So I've got, look at the variables here. I've got flipper length on the x-axis, hue to separate out the different species, and to separate out the two different sexes, the males and the females, I can do row, right? And so here we get one plot for males and another plot for females, right? And interestingly, there seems to be quite a big difference regarding for Gen 2, the distribution of flipper length for the male and female penguins in Gen 2. Okay, I don't know, whatever, that just happens to be in the data. Okay, you can create lots more. You can specify row, and then over here I'm going to specify for the column, as far as the plots go, different islands. Okay, and so there are 3 islands, and so we can say, okay, island Torgerson, and apparently on this island there's only Adelie penguins. All right, and so this is the distribution for males and females. On the Biscoe Island, there are Adelie and Gen 2 penguins, and these are the distributions for male and female. And then on the Dream Island, there's Adelie and Chinstrap penguins. Okay, and this is, so Adelie is everywhere, but then I guess Gen 2 is limited to one island, and Chinstrap is limited to another island. Okay, and so that kind of is revealed when you have a facet grid, where we're basically doing the same plot but for different subsets of the data split out by this. Okay, if you want to do something, so the distribution plot kind of has this built in where you can do row and columns, but if you wanted to do something like that for something else, like there's the histogram plot or something like that, you can create a facet grid, and you do seaborn.facet grid, and you're going to say, I want the facet to create different columns for each sex. So one column for male, one column for female. And then after you create that, you use g.map. And then you say, what is the function you're going to map? You're going to map this function, the histogram plot, with these arguments, and it will run this command, one for each different facet of the thing. So this is just, here's the histogram plot for sex equals male, here's the histogram plot for sex equals female. If you wanted to, you can do it for other variables, row equals day, and when you map something to the facet grid, it doesn't have to be a Seaborn thing. So here I'm just doing plt.hist, okay? From matplotlib. Matplotlib's base histogram function, which does this. And so, in comparison to Seaborn, suddenly the matplotlib histograms feel so much more basic, right? But they're perfectly fine histograms, but yeah, Seaborn just kind of does a nice kind of touches, right? And again, the facet grid, you can specify a row for, both variables, row and column, using a different categorical variable here. All right, so I've got, for lunch versus dinner, and so on and so forth. I gave you just one view quiz answer. All right, let me give you your second two, or the second and third. Okay, second one is A, and the third one is E. A as an apple, E as an elephant. Second answer is A as an apple, third one's E as an elephant. A and E. Okay, there are, if you have just one categorical variable, you can do a count plot. And, you know, I always call these bar charts, but Seaborn calls them count plots. I guess that's fitting. And then you can have like multiple variables, you know, one variable for X and another variable for the color. Here's the time or something. And then just kind of like fitting, again, like trend lines, you can do like LM plot. It'll fit like a trend line to your data. You can have like, instead of a straight line, you can fit a low S curve. And again, you would not be able to recover, even though you fit this, you're not going to be able to get like the slope and intercept. That's against Seaborn's philosophy, which is just do this for just exploration. See if there's something interesting there, okay? Here's the kind of residual plot, and you go, oh yeah, you know what, maybe maybe we're violating some assumptions about, you know, heteroscedasticity. Another thing is with the LM plot, when you fit like the linear thing, you can specify a categorical variable. So I'm going to do hue equals smoker, and here it's going to do, you know, the orange dots and the blue dots for whether they are a smoker or not. And we can see, you know, is there a difference in the slopes? And it looks like, oh yeah, maybe there is a difference in the slopes. Again, you would not be able to recover what those values are, but this would kind of tell you this might be worth exploring, you know, to see if there actually is a relationship. Okay, so that's Seaborn. Again, you think of Seaborn as like kind of a set of templates that are available for data exploration that, you know, I think makes streamlines some of like working with Matplotlib. So it's all built off of Matplotlib, and so you have to load Matplotlib first. But there's a lot of different examples of some of the things that you can kind of do this. And so yeah, I think this is the plot I showed you exactly, that one. And you can kind of look at some of the other examples in their gallery regarding like, oh yeah, you know what, this looks kind of cool. Can we do something like this? So on and so forth. Okay, so look at the gallery. I showed you just like a handful. I think some of probably the most common and most frequently used ones, but there are, you know, a lot more that you can find. All right, we'll wrap it up there. Have a happy Halloween. We'll see you all on Wednesday, and have a good and safe rest of your day.